If you're an early stage Web3 founder, apply to our award-winning accelerator program, Basecamp, at outlierventures.io/Basecamp. We write your first $50,000 check and give you access to 200 mentors, including many of the leading Web3 founders, and a network of 1,000 of the world's leading investors and exchanges. We've helped over 30 startups from 15 countries from all around the world raise $130 million in growth funding and can help you fast-track product market fit and, where relevant, the launch of your token economy. Okay, so today I'm really happy to welcome on Jason Teutsche, founder of Truebit. Welcome, Jason.
Thanks for having me, Jamie.
So we describe Truebit as a scalable verification solution for blockchains, scalable trustless computation. Truebit is a blockchain enhancement that enables smart contracts to securely perform complex computations in standard programming languages at reduced gas costs. So sounds too good to be true. You're going to tell us why it's not a little bit later. So reasons why I wanted you on the show. We've known each other for over a year, maybe 2 years now. I can't remember when we first started speaking.
It's probably longer than that, but it's...
Time is a weird phenomena in this space, right?
It is. In crypto time, it seems like about 50 years, but you and I are dinosaurs in this space, I think.
Yeah, probably. So I've known you for a while, been following what you've been doing at Truebit. You're a established academic, 17 journal papers from what I could see, a similar level of conference papers. For the uneducated, what's the difference?
I think that's a good question. So the conference papers are obviously proceedings for a conference, and the journal papers are proceedings for, well, they're not proceedings at all. Mostly they're actually just publications that went into journals. It's kind of the old-fashioned way. But when you work, so my academic career, I've worked between mathematics and computer science. Each field has its own way of disseminating the information, and math is a very much, they've always run journals. In computer science, the way that you get, you work your way up is by publishing conference papers and presenting over there. I mean, obviously computer science is a much newer field, and so the conference cycle is much faster. So I guess that's one way we do it. One reason that they run it that way. I mean, we can go into the reasons why the fields would work, but
maybe that's a podcast in and of itself.
It's because I'm between two different fields that have two different systems.
Okay, got you. But across those, I guess, you develop distributive system security with a special focus on cryptocurrencies. And you're interested in how proper financial incentives can allow us to build powerful new systems. And the opposite is also true. Misplaced incentives can have dangerous consequences. And so some of the papers, I guess, relevant in a crypto context are smart pool, practical decentralized pooled mining, smart contracts make Bitcoin mining pools vulnerable. And then in financial cryptography and data security, that was about Bitcoin in 2017, when cryptocurrencies mine their own business in cryptography and data security. And I believe you even collaborated with Vitalik, obviously co-founder of Ethereum, on a few as well. I guess maybe you could just talk us through a couple of those and some of the insights that they expressed.
I started off my PhD in mathematical logic, did a dissertation in computability theory, and I see these same sorts of games, I guess you can say. If you look at the early papers, they are about sort of those crypto economic incentives. I mean, there wasn't, the word crypto economics didn't exist when I started doing these works. The first paper was on the verifier's dilemma, which explains why does Ethereum need to have a gas limit. It goes beyond that. We want to prevent denial of service. It's if you don't have a gas limit, you actually will end up breaking the consensus of the network. And so, these were some, at the time, kind of a simple observation, but hadn't been sort of made explicit, I guess, in any way before. And I guess exploring Nakamoto consensus, the 38.2% attack paper, which is the one, I think it was called When Cryptocurrencies Mind Their Own Business. Like basically we said, what happens if if you create, fork of the network and you put out a reward you issue a smart contract which says solve this mining puzzle over here and get a reward. Some of the miners are going to come off the main chain and start mining over there. And we found this magical number, 38.2%. If you have that much power in the network, that you would actually, with a very small amount of capital, it would be profitable to offer these rewards. You can pay out the rewards on the other side and then make more money than you would through ordinary mining. So that was kind of the flavor of the things that we were interested in looking at in those times. But yeah, basically, I think ultimately, the verifier's dilemma was the precursor to Truebit. That was, a few papers later, verifier's dilemma led to the Truebit white paper, which most people saw in 2017, and I think was one of the, it was an important paper in crypto economics, because I think it was certainly the most complicated smart contract that had been described at the time, and sort of, I think it opened up a lot of questions and helped people to think about, things that people sort of take for granted now in the crypto space, how incentives work and, designing protocols, so all that stuff. And then, of course, later, as you said, we came to the paper when a few months, but shortly after the Truebit white paper, but things got really crazy with the ICOs, and Vitalik wrote a blog post about sort of the different mechanisms people were using in 2017 to play ICOs. It was a crazy time, to say the least. And all of them, there were many different protocols. We came up with one called the interactive coin offering, which was supposed to solve some of the problems of basically the two basic forms of crowd sale, the traditional and the uncapped sale, where you just buy in. There's no certainty of valuation. You don't know ultimately what percent of the network tokens you're going to end up with. And then the cap sale, where most people don't even get in at all. So that was sort of and Vitalik came with a very simple argument that's saying, you can't have certainty of valuation and certainty of participation, because if each dollar buys a P% of the network, then you can't sell more than 1/P in total of those tokens. So Vitalik and I looked at that, and we came up with something that was supposed to sort of maximize the information for the buyers and help it reach an equilibrium price, I guess, at the time of the launch. Because I think a lot of people were going into these things sort of blind. What you're actually buying in terms of sort of the economics of the token. So anyway, so that was it. Even if you look at Dutch auctions, it was similar. Like people said, people will buy in when it's actually the right value for them. But we saw stuff like the Gnosis ICO where everybody, they jumped in the first 10 minutes and they sold out, and Gnosis ended up with 95% of the tokens. And so there was still sort of this, I guess, FOMO challenge that was going on in a lot of those things. So yeah, it was a kind of an anti-FOMO protocol in some ways. But I do think that, going forward, that is a protocol that could be interesting. We've heard SEC chairman, soon to be departing, talking about issuing securities over blockchain technology. And, this is, I think, in that sense, the IICO, even though the ICO craze may be over. I guess we still see some ICOs today, but it's not the same market where you would necessarily test those tools. It could be something that people would use when they're doing an initial public offering in the traditional equity sense. And I think that it is a sort of a nice way of finding the market price for that. So it makes most sense on a blockchain, but anyway, so.
It's still a challenge, right? Projects are still exploring a number of different things, from bonding curves, various flavors, as you say, Dutch auctions, all to establish, price discovery and try to match supply with demand in a fair way. But as you say, ultimately, with the benefit of blockchain, there's a degree of transparency, but it's still it's not quite a science yet, right? It's still pretty imperfect, and people are experimenting with different types of mechanisms. So if I kind of just jump back to your academic career, you've had a number of postdoc positions, including at NUS, Penn State, University of Heidelberg. You've had a US Fulbright Fellowship to Israel and then to Hungary. I believe you've also worked at the RAND Corporation. Could you talk us through a little bit about that kind of academic background or journey?
Yeah, I mean, I guess I would say mathematics is the best way to see the world, right? I mean, like it or not, you end up going to all these different places. So yeah, I guess I had a lot of great mentors along the way, in a lot of different areas. I think have sort of shaped and then allowed me to I guess branch out into a lot of areas that were beyond, I guess, my dissertation and so forth. So yeah, I mean, I've always sort of been between math and computer science, but certainly doing stuff in. I rode the algorithmic randomness wave for a while. Back in starting in, I don't know, 2007, 2008. I was always close to Kolmogorov complexity because I was, the dissertation was about shortage computer programs, so it's not a gigantic leap. And then, had some stuff like when I was at Penn State doing some of these early stuff on network security. And, I sort of saw coming into crypto was a place where I saw a lot of these different pieces come together. As you know, it's a very interdisciplinary space, and I think that's something very attractive about it. And in fact, it was a very big challenge that we had in the beginning for working in blockchain, because, when you looked at, I found myself writing papers which didn't, and we talked a little bit about the different boxes in these different fields. And I had something like the Truebit white paper, which I should say, was well regarded in the space of cryptocurrency, but it didn't, you couldn't send it to a math journal because they say you didn't prove anything. You couldn't take it to, computer science because they said, well, typically you have to actually build out the system. And then economics, they're just like, well, what the hell's a blockchain, right? So it's kind of like, I was sad because I said that sometimes, there's some journals that couldn't even get a referee report in some cases. So that was another thing that I started realizing that, we needed, when we started a while ago, the tokenized journal, which was supposed to be using tokens as a scalability way of processing all the scalability solutions. Because even though when we started Truebit, we were one of the early papers, I guess, thinking about scalability because, well, frankly, there was no network, so there was no congestion. But eventually, we saw by the end of 2017, beginning of 2018, everybody was concerned about scalability, and there were so many white papers that at least I lost track. So anyway, that's a little bit about the background and all these pieces coming together.
So then if we fast forward to Truebit, as you said, the basis of Truebit was a white paper. Obviously now it's a startup, you're a founder, and I believe you're coming close to mainnet. Could you just talk us through the problem that Truebit solves? And I guess why, you're a smart guy, as you say, you worked in a number of different disciplines. Why this problem? Why is it this problem that has occupied your waking thoughts?
So let me answer the first question first. Both are good. So in terms of the use case for Truebit is pretty simple if we think about it in terms of Ethereum mainnet. Part A is that by using Truebit, you can save tons of gas relative to the native execution. And also, and that includes sort of performing computations that would otherwise exceed Ethereum's block limit. Sometimes there are cases even where if you could fit in the block limit, you might not want to do that. You want to write, say, for example, part 2 in a standard programming language. So using standard libraries, you don't want to have to re-engineer stuff into Solidity. In some cases, it's probably impossible to do it anyway. So basically saving tons of gas, writing in standard programming languages. The other thing is that, Truebit obviously has also a file system, which is allows us a way of getting data into and out of the blockchain. So in a sense, you can think of it as a way of making smart contracts a bit more powerful and easier to use for certain types of applications which have a lot of computational complexity. So I think, and I think that's also to answer your second question, that ties right back in. I mean, it's this idea of computational complexity. I mean, the simple question that we would ask is, well, smart contracts are great. They can compute very small things. What if we could actually do real data processing in a smart contract? What sorts of doors would they open? And I think, as we went further down this rabbit hole, we found it just to be more and more interesting, because we realized that in order to answer this question, part of it is the design, right? There's sort of this crypto economics, which is I think, obviously fascinating piece. But then when you actually go and try to say, well, how are we going to implement this? There comes a lot of architectural details. We were one of the first projects to experiment with WebAssembly. I mean, if you look back at the Truebit white paper, we talk about building it with Google and I, because in 2016 that seemed like the best option. And of course, you probably never heard of Google and I, because we needed very simple architecture so that we could play this verification game. So I think there are all those pieces to it. And then of course now, getting, as you said, we became a startup, getting into the aspect of sort of the product market fit to say, gosh, this is just fascinating, but what is it? How are people really going to use this? And so I think that's fascinating that we've taken something that in 2015 was really pure science fiction to where we are now, which is a product that people can use. And so that's what I'd say.
So could you talk us through specifically how? I mean, would it be fair to regard this as a layer 2 solution for Ethereum, and how do you solve for allowing greater complexity in computation, and are the trade-offs, or what are the trade-offs?
It depends on your definition of layer 2. Truebit was around before the word layer 2 existed, so which is typical of most new research, right? The layer 2, I mean, it's usually associated with like plasma, optimistic rollup, this sort of thing. I think one distinguishing factor in the technology, Truebit is a stateless system. If you're working in plasma or optimistic rollup, you see systems that are sort of, if you use them, you're operating inside of their own virtual machine. And I know that's confusing because Truebit also has its own virtual machine, but that is sort of, if you're just a user of Truebit and it's just a black box, you don't see that. It's just your smart contract. When I say stateless, I mean basically pure function. You got a function F, you got an input X, and your smart contract sends those to Truebit, and Truebit calls back with F of X. That's basically all it does. There's no complicated thing. And it's also, part of that is also hidden by sort of, I guess, the economics of the system, that it's basically, sort of plug and play. You stick your function in and you go. You don't need to necessarily worry about being involved in the verification process or carrying your transactions back to the main chain or something like that, because we never really leave the main chain. So, and then of course, using the WebAssembly architectures allows us to write stuff in C, C++, Rust standard compiling. And so yeah, and it is, and the other thing is, I would say, is that it's scalability from a very special, particular point of view, in that less focused on transaction throughput and more on just, we're happy if we get one really big one to go through. So that's all, I guess, how I would break that down.
So as you say, this isn't to solve for, transaction volume on Ethereum. This is allow you to perform particular functions with greater level of complexity. So could you give an example of the type of use case where this is relevant?
Yeah, sure. I mean, I think we're all familiar with DeFi at this point. Basically we see, anybody who's doing DeFi is doing some sorts of computations with their protocols. We have a dark pool, for example, that use Truebit for settlement of the transactions. So in other words, they have their own zero knowledge proof system, which is basically multi-party compute, where people put in buy orders, sell orders, and then they're basically matched on chain, and you can use Truebit to prevent any sort of cheating, front running that would be invisible if you were putting that into like an OTC desk. So that's kind of a simple example. I mean, a more perhaps basic example is, say you have a DeFi protocol, you have this derivative function that you want to compute. You don't want to write your own square root function in Solidity. Maybe you're using other sorts of stuff. You just need this processed in a way that's secure. In other words, you can send off your compute to the Truebit and get the derivative done over there. So that's sort of, I guess, a couple simple examples. Obviously, we've seen all sorts of creative things like, Live Peer using this for video transcoding. I mean, it is capable of doing that. We have the FFmpeg library. We can compile to Truebit tasks. So yeah, I guess there are a lot of possibilities, but I think, in this time, in this space in Ethereum, it's sort of obviously most of the applications are running around DeFi. So that's what we're supporting.
Understood. And so you mentioned a couple of times the kind of crypto economics of the system, and given your background, I imagine this is something you put a lot of thought into. Could you talk us through, how the incentives and disincentives are designed to make this system optimal?
Well, yeah, that's probably a longer conversation, but to put it like very simply, Truebit is based on 3 layers. One is a basic dispute resolution layer, which we use, to say and then this is sort of the foundation of how we're able to guarantee the correctness. If a solver comes in and says, I have a solution, verifier doesn't agree, then they're going to do a kind of binary search to find the first place in that step in that computation where they disagree. And that step should be small enough they can run it on chain. We sometimes refer to that, that resolution done by the Ethereum miners. We call them judges because it's sort of like a courtroom. So on top of that, you have this incentive layer that's supposed to create economic incentives for people who would show up to do the protocol, participate in the protocol. And the main roles there are solver, a task giver, let's say, who creates a task that they want solved. So presumably coming from a smart contract in the case of Ethereum, and then a solver who's going to provide a solution, and a verifier who provides an answer, and then the economic incentives to make sure that these people actually show up. There was the idea in the white paper of this forced error, which occasionally the solver should make a mistake so that the verifier is who gets rewarded for finding bugs. There are actually bugs for him to find. And the verifier doesn't know when the bug is going to happen, so the solver is always being watched. The solver always behaves correctly, even when it's not a forced error. So, and then on top of that, we have this token economics, which is more of a macro layer to see how does this system evolve over time, and critically, how do you price the token, the token price, to make sure that it's meeting the needs of those people who are participating in the system. So yeah, I guess that's in a nutshell the pieces.
What is the, like, for you personally as an academic, as an innovator, as a founder, what is the commitment to making things work better or extend the possibility on Ethereum specifically, rather than going off and trying to create a new protocol or,
So I guess, Ethereum there are a lot of developers on Ethereum. So there's just the use case is very clear. So I think it's a very natural place to start. Obviously Truebit is, as we said, it's a pure function protocol. We can pick it up and drop it off on another blockchain or elsewhere. And so I think there are those other possibilities, but just because it's very easy to use on Ethereum. And originally, my co-author of the Truebit white paper, Christian Reitbiesner, was also the creator of the Solidity programming language, which is a language that people use to write smart contracts in Ethereum. We've always sort of, I guess, been a little bit biased towards the Ethereum tooling, and frankly, the whole world is been a bit biased towards Ethereum because there is so much tooling, and that it's easy to, we've seen a lot of projects start with Ethereum tools and modify them when they create their own blockchains. So I think it's very, just as they can do those modifications, we can certainly bring Truebit over there when it makes sense. So
understood. Okay, so it's a starting point, not necessarily
I think
exclusive.
that's right.
Yeah. When I've spoken to you in the past, and I believe this came about from conversation with Charlotte, was now Kapoor, probably Charlotte Baker previously, she got married recently, of Outlier, around how you communicate your approach. So one is the technology itself, as we just discussed. The other one is this kind of crypto economics layer. And I believe in that conversation, what came up was this idea of a microeconomy. And I know you've been, you're based in the US. You've been committed to proactively engaging with regulators to help educate them, help them to understand, I guess, the utility that you're trying to bring about beyond this being perceived by them and presumably the rest of the world as just kind of a new protocol to speculate on. But you've referred to that as a microeconomy, this approach. Could you just talk us through that? And I guess, whatever you can share about that conversation with the US regulators and how they're perceiving this type of approach.
So I would say, first of all, I give credit to Charlotte for coining the microeconomy. That's all Outlier, and I think that helps us to frame what we're trying to do with the token, and it really indicates that it's sort of a user focused. We're interested in something which is sustainable and meets the needs of the users on the platform. And I think, as you said, the regulators do play into that a bit as well. I mean, the most general thing I can say is that, I think everyone should pay close attention to the regulators, A, because you want to stay on the right side of the law, but B, because I think they're actually there to help us steer us in the right direction, which I think, when I say right direction, I really mean a sustainable direction, a system which is purely based on speculation. If everybody is investing and they want a return, that money has to come from somewhere. So, in order to make something sustainable, we got to see an inflow of money and not just an outflow. And I think that's why the regulators are there. And if you look closely at what they're saying and look into the details and don't try to brush them aside, but actually try to design your crypto economics around the messages that the regulators are providing, especially the United States and the SEC. You can reach out to folks in FinHub, but they've also put out a lot of material as well. And I think you can go and just by thinking about these things and figuring out where's follow the money, where is it flowing to, and answering those questions, you will be able to answer better what value is actually being created, and is it sustainable, and if not, what do I need to do to sort of to tweak that? Yeah, you basically have a business that can persist.
Well, I guess one of the consequences of that, right, is that when I spoke to you originally, as you said, it probably is 2 years now. So Truebit, the startup, or I guess the transition from white paper to startup, has been happening over that 2-year period. And I think you mentioned off air before we came on that you're kind of close to this mainnet. So effectively, that's been in large part self-financed, right? You've had to get the product to the point of mainnet without raising external capital. Presumably to fulfill, I guess, for you, what is a moral and a regulatory obligation around utility, demonstrable utility in the network.
I think that's also right. I think there's also, if you start raising money on tokens, there's also an expectation from the community that comes along with it, right? I mean, if people are buying the token because they are expecting it to go to the moon, well, then, if that's what you told them you're going to do, then there's some obligation there as well. But I think, as I said, that's mooning a token is not really a sustainable business model. And so, frankly, from what I'm seeing, I know we're in some ways it's playing the long game. But the other thing is when you actually sit down and force yourself to say, okay, where's the revenue coming from? Just think, not just talking about where's the next investment coming from, but where's the revenue coming from? If you get down to sort of brass tacks on that, it really forces you to go out and answer these questions, which, I think now we've actually, learned a lot from being through that, from going through this process, and, are in a good position to actually take advantage of that. Yeah, all the things you mentioned. I mean, I think it's very disappointing. You can say it's great. You do the ICO, get the money in the door, but where are you going to be 4 years from now? When the regulator comes and who wants to unwind that stuff that you've put your life work into? So it's hard. I mean, I think striking a balance. I mean, it would be. It's hard. I mean, I guess, yeah, it's challenged. No matter how you do it, starting a business of any kind, whether it be crypto or whether it be, a traditional startup or even any kind of business, there's no substitution for hard work and figuring these things out. So yeah, I think,
I admire I was going to say, I admire the kind of disciplined approach. I'm all for supporting different pathways, obviously, especially those that are pursuing sustainability. I think when we've spoken in the past about proactively engaging regulators, I probably, having seen a few projects get burnt in that process, was probably quite skeptical. So, but at the same time, I'm hopeful that this pathway works out for you. And I think, clearly, there are benefits in having taken this hard path. Namely, you actually start, when you launch mainnet, you start with a blank canvas in a way. You don't have all of these, as you say, kind of stakeholders whose motivations might be counter to what you're trying to achieve with a wider network.
So to add to that point, I guess, is that you also end up with potentially a very excessive supply of tokens. I mean, that's something. Yeah, in the beginning, when there's a lot of demand, and the thing comes out, there's every crypto project goes through a certain hype cycle, right? But what do you do when that's over, right? I mean, when you have an excess in supply, unless you have a mechanism for recovering from that, you're not going to recover. So I think that if we can carefully control the token supply so that it is actually in line with the actual supply and demand of what the product is doing, then you have a solution to that problem.
Will that be algorithmically then? Is that the intent?
Well, I mean, it's algorithmically, but it's also simple economics. If you pre-sell a lot of tokens to people, what are they going to do with those tokens? Like, simple cases where you have just a placeholder token. I mean, the only thing you can do with it is buy and sell. If once you're sort of on the other side of the hype cycle, you end up with too much supply, and if you don't have a plan for how you're going to deal with that. I mean, it's much easier if you're starting from, as you say, starting from a blank slate. It's hard enough to get these things work. I mean, crypto protocols they can be very complicated, and I think that it's just something that you have to look past the inevitable cycle of supply and demand, and see if you could have to a place where people are continuously buying the token because they're using it to run, some other protocol, and there's sort of a steady stream. Well, then, you have actually sort of a much more sustainable thing. That's all.
Yeah. Well, I mean, I think, clearly if you look at the wider market, as you say, because there is a oversupply, often very early on in the maturation of a network, then it creates this perverse incentive where projects are either trying to artificially create, hodling behaviors, or more demand into the system based upon just meaningless announcements. Equally, trying to find other actions that remove supply, and that could be, staking, but where it's not really additive to the overall network. It's just kind of a way to remove supply. So you can, of course, see lots of patterns, right, as a consequence of that oversupply into the market. And so it's going to be really interesting to see how your network plays out. So maybe just round off, could you tell us a little bit more about mainnet and how people can get involved?
Yeah, so if folks who are interested in trying out the live network, you can go to the Truebit.io website and send a message at the bottom with include your GitHub handle. Actually, GitHub handle, but also tell us a little bit about yourself, like maybe what you're planning to do with the protocol, and then we'll get you connected. So yeah, and as we said, it'll be we'll be opening this up further to the public over the coming months. But for now, I think we want to get to know our users. So that's one of the reasons why we go through this funnel. And I guess the other thing I can mention is that, there is on the mainnet, we're having, contrary to the white paper that's on the website, it's just a single token model. So it's actually a bit simpler than that. And the token will, be obtainable directly through the platform. So you don't have to go to an exchange or anything like that.
Okay, great. Well, look, Jason, again, it's been interesting tracking your journey. I'm hopeful that you can set a precedent for how a different approach to bringing a tokenized, protocol live, especially in the context of the US and that kind of regulatory environment, and then hopefully a good precedent for proactively working with a regulator very early on, because again, there aren't that many of them. So I'm interested to watch how this one pans out. So Jason, thanks so much for coming on, and good luck.
Thanks, Jamie.
If you enjoyed today's podcast, please make sure you subscribe, rate, and share your feedback to help us reach as many people as possible with the important mission of Web3.